Hi to everyone. Let us continue with the next series of matrix eigenvalue problems. So in the previous section, we have seen how to find the eigenvalues and eigenvectors for the matrix A equal to 1 0 0 0 3 minus 1 0 minus 1 3, which is an 3 by 3 matrix. So here in this 3 by 3 matrix, we got the eigenvalue as 1, 2, 4, where the eigenvalues all are different. So we get the corresponding eigenvectors as 3, 0, 0, and for lambda equal to 2 as 0, minus 1, minus 1, and for the third eigenvalue our eigenvector is 0, minus 3 and 3. So now the next case is we are going to see the problem of same 3 by 3 matrix. Since it is a 3 by 3 matrix, we get the cubic equation as a characteristic equation. So in this cubic equation, we get the roots are two roots are same and one is different, which is a next method of finding an eigenvalue and eigenvector. Yes, so here in this problem we are given with the matrix A equal to minus 2, 2, minus 3, 2, 1, 6, minus 1, minus 2 and 0. So here, since it is a 3 by 3 matrix, our characteristic equation formula is lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. So here S1 is sum of main diagonal element, which is minus 1. S2 is sum of minus of main diagonal element, which is minus 21, and S3 is determinant of A, which is 45. So while you are substituting all these S1, S2, S3 in the characteristic equation formula, we get a cubic equation. And in step 2, we are finding the roots for this characteristic equation, which is named as an eigenvalues. So the eigenvalues of this above cubic equation is minus 3, minus 3, 5. So since minus 3, minus 3 two roots are same and third value is 5. So we are going for the second method of finding the eigenvector. So as we know, the step 3 is finding eigenvector by using the formula of A minus lambda I into x is equal to 0. So here A is the given matrix minus 2, 2, minus 3, 2, 1, 6, minus 1, minus 2, 0, minus lambda is the given eigenvalues, which is calculated eigenvalues, clear, and I is an identity matrix, and x is x1, x2, x3 and 0 is remains same. So when you are substituting the eigenvalue lambda as minus 3 here, we get the equation as 1, 2, minus 3, 2, 4, minus 6, minus 1, 2, 3. The column vector x1, x2, x3 equal to 0. Here, when you are saying all the 3 rows of the matrix, it looks as different. But when you are analyzing it, we can see all the 3 rows are same with the values of 1, 2 and minus 3. Yes. In the second row, when you are dividing it by 2, we get 1, 2, minus 3. And in the third, it will be when you are taking a negative sign. As common minus 1, 2, minus 3 you will be getting. So all the 3 rows are same. So when you are taking a cofactor for any one of these 3 rows, we get an eigenvector as in 0, which should not be happened. Always eigenvector is a non-zero vector. So for this case, we are taking an any one row of the above matrix and rewriting in terms of an equation, that is converting into an equation, that is x1 plus 2x2 minus 3x3 equal to 0. So here we are going for assumption method. So put x1 equal to 0 so that we get 2x2 equal to minus 3x3. By finding the cofactor for that and by cross multiplying, we get the eigenvector for x1 as 0, 3 and 2. And when you are putting an x2 value as 0, we get x1 and x3, which will be act as an second eigenvector 3, 0, 1. So here why we are putting the same in the same equation, giving value for x2 as 0 means, since the two eigenvalues are same, when you are substituting the second eigenvalue in the same determinant A minus lambda equal to 0, we will get the same equations, all the 3 rows are same. So it will be repeated. So in that case, we are assuming an x1 as 0 and getting an eigenvector, and for second eigenvalue which is a repeated eigenvalue, we are going for the next assumption x2 as 0, so that the next eigenvector for x2 equal to 0 as 3 0 1. And for the next third eigenvalue which is lambda equal to 5, which is different from the other two, so in substituting that we get matrix as -7 2 -3 2 -4 -6 -1 -2 5, and the column vector as x1 x2 x3 equal to 0. So here, since all the three rows are different, we can take as usual by taking a cofactor for any one of those three rows. So now let us take a cofactor for first row. So we get the eigenvector as x1 x2 x3 is 8 16 -8, that is 1 2 -1. So likewise we can calculate the eigenvectors to the corresponding eigenvalues. So here in this second problem of 3 by 3 matrix, we have seen the repeated eigenvalues. Yes, so when it is a repeated eigenvalues, we have to go for assumption method when all the three equations are same to find the two eigenvectors. And for the third eigenvector, we can go for substitution in the matrix and get the third eigenvector. So for 3 by 3 matrix, we get the characteristic equation as a cubic equation, and for when you are solving, you get 3 eigenvalues and the corresponding 3 eigenvectors should be calculated. So always remember that eigenvector should be a non-zero vector. Thank you.